Hi, my name's Misha Koletsky. I am the author of Expect Type, which is a library bundled into VTest that helps TypeScript developers provide compile time tests for their types. This is to make sure that your types don't accidentally change or get worse over time, or that they do what you think they do in the first place. I'm going to show you how it works, why it's useful, and how it's built into VTest. There's nothing you need to install. If you're using VTest, you already have this available to you. So first, why it's useful. Most of us, I think, use TypeScript to catch errors. There's also obviously benefits like IntelliSense in IDEs, but it's also to make sure that when people use your code in future, they're going to use it in the right way. What it doesn't necessarily protect against is if your types are, say, too flexible, or if they change in future to allow any's or something like that. Expect Type lets you explicitly test what your types are supposed to do to catch any future issues before they become bugs. But it's purely at the type level. It does nothing at runtime, but I'll show you an example. You can fit it into your existing VTest tests. So we can jump into an example. Let's say you define a function, super useful module called calculator.ts. So in this example, we've got a number that we are adding to another number, and we expect the output to be a number. We want to make sure that the output type is correct. So here's what a test for that function might look like. You basically just call expect type of add, and then you pass in what you're trying to test into this helper function, and then you can run tests on both the parameters and the return type. There's a lot of different helpers that I won't go through all of them in this talk, but pretty much everything you might want to do with a TypeScript type, there's a helper for. So you can see if you type to be, we can say I expect the return type to be a function, and then I'm going to get what's hopefully a helpful error. So you might have seen Vladimir's talk about this a year ago, and there were some caveats around it. This was already part of VTest in an experimental capacity, and the error messages weren't that great. It basically said, "You're wrong. This isn't a function." We've done a lot of work on improving the error messages because this is a pure TypeScript library. There's nothing fancy happening at runtime. There's no crazy hacked version of TypeScript that you have to download. This is just using the TypeScript compiler. So some of the error messages are still a little bit strange to read because TypeScript doesn't expose this kind of thing at runtime. So there's a ton of crazy TypeScript generics. There's TypeScript ternary operators inside this library. You shouldn't really need to worry about any of that. All you need to know is roughly how to read these messages. So let's say I expect add to return a function for some reason. I'm going to get an error message that is as close as we could get it to human readable. Obviously, feedback welcome. But basically, the way you read this is type expect function number has no call signatures. So the reason we've gone for a call signature error here is so that the error message actually includes what the expected type was and what the actual type was. So we're going to change this to be number. And this is roughly equivalent to be number is roughly equivalent to equal type of number. It's not exactly the same because I can do things like this. And then we can say the type 1 rather than, which has type literal 1 rather than number, that is a number. So you can use some of these helpers in different ways. It's worth experimenting with. So let's say we want to add some features to this calculator, like let's say we want to support big ints as well. Okay, so now we should see, oh look, this is great. I'm running the TypeScript compiler, and this is just regular TSC. You can also run it through VTest. And VTest will show you exactly which test has the type assertion problem. And we're going to see that there is a problem in one of our tests that existed. Now we've got an overloaded function, and expect type of actually handles overloaded functions in a way that I would say is better than the TypeScript built-in option. So the problem here is that now the parameters are either a tuple of type number, because A could be number and B could be number, or it's a tuple of type big int. So if we change this, then we should see the error message go away, or big int. And then that one goes away, Cursor is guessing what this is. And similarly, the return type, it may be a number or it may be a big Int. This kind of mostly covers your bases because the parameters have type either that left-hand side or the right-hand side, and the return type has either number or big Int. But obviously that return type, we want to make sure that that's not actually a union type that returns from the add function. You want to make sure that if you pass big Ints in, you get a big Int out. So we can actually test for that using expect type of, without even calling it at runtime as well. So let's say expect type of add, we can use the helper to be callable with, and then we can say, yes, this type is callable with 1, 2. And then the nice thing about this is then we map that to the correct return type. So if we then say returns, we will get returns to be number. And similarly, I can say, we actually don't have the big Int helper yet, but to equal type of big Int. To be big Int is something that we need to add. It's just a missing helper, but like I said before, you can just use to equal type of big Int there too. So you can see this helps make sure that that number is mapped to number, and then we don't need to worry too much about the way that we did this casting. Obviously, this overload syntax is not the most familiar to all developers, so you might look at it and think, are you going to get number or big Int return type when you actually call this with big Ints? But you won't. This can make sure that you've written the overload syntax in the right way, and these are the actual only two signatures that get exposed through the add function. Here's another slightly more involved example. I've got a module called ZAD, which is used to create schemas that can validate input objects and make sure they match a certain shape. In this example, I've got a person schema, and I'm making sure that they have a name property that's a string and an isMarried property that's a Boolean. If I want to add an age, I might do something like this, and then you'd expect this to start failing, and then I would add an age number property here, but then this helped me find a bug here. So if I look at the error message, it says expected number actual string. So if I go back to the implementation here, I'm going to see that this is the problem. I've got val is string rather than val is number. TypeScript is not going to find this error for you because type guards just kind of almost allow you to do anything as long as you're returning a Boolean. So this is a place where this kind of testing library can come in really useful. Another way that you can see is it actually protects you against any, which can be the scourge of a lot of TypeScript code bases. If I change this to val is any, this is still going to fail. The error message becomes a little bit harder to read because we have to map any to never in order for it to not match. But basically, we can see here that these types are not identical. So we really do a proper identical check. It's not just making sure that type A extends type B and type B extends type A. Any will not be allowed to match against number. So it's quite nice the way it checks for that kind of thing. There's also a lot of checks that if you were implementing something like this from scratch, you'd come across a lot of these edge cases. Let's say I want to add an optional helper, and then I make age optional to make it a backwards compatible change. You can see that what Cursor is suggesting here is that I just add a question mark to the age property, but that's still not quite going to work because you can see if you read the error message, one of the types has age as a truly optional property, but what we've got is age as a property that can have either type of number or type of undefined. So to fix that, I'm going to just take a shortcut and use typefest.partial on undefined deep. There are lots more helpers to dive into. For example, if you want to do only partial matching on a type, similar to the toMatch object method that exists on expect, you can do expect type of person to match type of name string, and that will be the equivalent of the toMatch object function. There are tons more. Have a look at the docs. They're on the VTest website, and they're also on the NPM package expect type. Thanks a lot for making it this far. Here's the NPM package. The GitHub repo is linked here. VTest is downstream of this package, so development happens here. And give me a follow on Twitter as well. I'll be talking about upcoming features of expect type, and there's tons and tons more usage documentation on NPM here, and this is also copied onto the VTest website. Thanks, bye.